So what are we going to do? We are going to prove that number one, the d by dt of E rho, the unit vector along rho. This is equal to phi dot. Phi dot, dot means differentiation with respect to t. So this is d phi by dt times E phi. First, I'm going to prove the second, the proof the d by dt of E phi. E phi, this is equal to minus phi dot E rho. Where dots denote differentiation with respect to time. With respect to time t, where dots denote differentiation with respect to time t. Where dots denote differentiation with respect to time t. Okay. Proof. So to prove the first one, let us remember this. What is E rho? E rho is cos phi I cap plus sin phi j cap. So let us use this first. I repeat, E rho equal to cos phi I cap plus sin phi j cap. So we know that E rho is cos phi I hat plus sin phi j hat. Now let us differentiate this. Therefore, d by dt of E rho. This will be what is the derivative of cos phi? This is minus sin phi d phi by dt, which is phi dot. So this bagi differentiation d minus sin phi times phi dot. So there should be a bracket here. I hat is a constant vector. So my d derivative 0 ni. Constant on thamaga, you simply differentiate this. Whereas E rho is not a constant, so its derivative with respect to time is not 0. But I is a constant, therefore its derivative with respect to time is 0. I is not time give there should be two terms. Let's see this sin phi times j. J is a constant, so I leave j as it is. Differentiate sine. Sine की derivative थी cos phi. Phi के derivative lower d phi dot j hat. And what is this? This is nothing but you take phi dot common. So you take phi dot common, and this is minus sin phi I hat plus cos phi j hat multiplied by phi dot. Aduga minus sin phi I hat cos phi j hat. What is this? E phi has E phi is minus sin phi I hat plus cos phi j hat. Therefore, it's nothing but E phi. So E phi mana recall. This is E phi. So this is E phi. So this is E phi, and we have phi dot here. So this is phi dot times E phi. So this first we have proved. It's there. Next, second jam prove the. Let us prove the second one. To prove the second one, E phi is. What is E phi? E phi is E phi is this. E phi is minus sine phi I hat plus cos phi j hat. This is E phi. Now let us differentiate this with respect to time. So dy dt of E phi this is equal to, let us differentiate this. Minus sine phi derivative minus cos phi the phi dot. So this will be minus cos phi dot times I hat. What cos phi derivative minus sine phi dot j hat. So I can take minus phi dot common log. So what do we have? Cos phi I hat plus sine phi j hat. And what is cos phi I hat plus plus sine phi j hat? Cos phi I hat plus sine phi j hat is nothing but E rho. So this is nothing but the minus only minus phi dot E rho hat. So we have obtained two important relations. That is the derivative of E rho with time is nothing but phi dot times E phi, and the derivative of E phi with respect to time is this is nothing but minus phi dot E rho. Now using this, let us express the velocity and acceleration of a particle in cylindrical coordinates. So using this, let us express the velocity and acceleration of a particle in cylindrical coordinates. So to express the velocity v vector and acceleration which is represented by a vector of a particle in cylindrical coordinates. So to express the velocity and acceleration of a particle in cylindrical coordinates, first let us express the position vector. Velocity and acceleration in rectangular coordinates. Rectangular coordinates in rectangular coordinates. In rectangular coordinates, the position vector is given by r vector equal to xi hat plus yj hat plus zk hat. Xi hat plus yj hat plus zk hat. This is the position vector. The velocity and acceleration vectors are given by the velocity and acceleration vectors are given by velocity v vector equal to what? V this is dr by dt. Dr by dt, and that is equal to x dot I hat plus y dot j hat plus z dot k hat, where dot denotes differentiation with respect to time t. So I give the Nicole. Similarly, acceleration. What is acceleration? Acceleration is rate of change of velocity with time. So this is differentiation of this again with respect to time. Then we have x double dot I hat plus y double dot j hat plus z double dot k hat. Go. In cylindrical coordinates, in cylindrical coordinates, R vector equal to x I hat plus y j hat plus z k hat. What is x equal to? Again, this is equal to, what is x in cylindrical coordinates? X is equal to rho cos phi. X is rho cos phi. And in cylindrical coordinates, what is I hat equal to? I hat. As you can do, in cylinder, I hat is equal to cos phi e rho minus sin phi e phi. I hat I hat equal to cos phi e rho sin phi e phi. So let us convert. This I hat in terms of rho hat and phi hat. So this is I hat is nothing but cos phi e rho minus sin phi e phi. So this is x, this is I hat. So mind of plus what is y? Y is y is sin phi, rho sin phi, rho sin phi. This is y. And what is j hat? J hat in terms of e rho and e phi. What is j hat? In terms of e rho and e phi, j hat is sin phi e rho plus cos phi e phi. Okay. So let us write the value of j hat, and j hat is sin phi e rho plus cos phi e phi. There you go. And what is z k hat? Z is nothing but z is k hat will have e z. So here we have expressed our position vector, R vector, in terms of rho, phi, and z, and their unit vectors. When we simplify this, okay, so let us simplify this. Rho cos phi. So first term will be rho cos square phi. This will be rho sin square phi. So e rho common hoga. So what do we have? Rho cos square phi plus sin square phi times e rho from this term and this term. Rho cos phi minus sin phi e phi. Rho sin phi cos phi e phi. So these two terms will cancel out. Aduna siga multiply toroga phangbuduga, siga multiply toroga phangbuduga. These two terms will cancel out. So what remains is only plus z e z. So what is cos square phi plus sin square phi? This is always 1. So this is nothing but rho e rho plus z e z. So in cylindrical coordinates, the position vector is given by rho e rho plus z e z. sida khoni yengum matamda cylindrical coordinates study aigi rho, phi, and z. These are the three coordinates. So the position of any point, is determined by the values of rho, phi, and z. adu orgadi sigi position vector sidai phi ki term yok karigino na koi khanbe ay. Why is there no term containing phi in this position vector? adu munne yengjeloragadi e rho haibase, this depends upon phi. Masi phi ki makha poligo. What have we seen earlier? We have seen earlier that e rho depends upon phi. E rho is cos phi I hat plus sin phi j hat. So she had yang the phi out of malamani, but we should remember that e rho contains phi. Position vector z, it is a function of rho, phi, and z. So this okay. So this is the position vector. Then let us calculate the velocity. Then velocity, what is velocity? Rate of change of position with respect to time is v equal to dr by dt. And what is r? R is this. So let us differentiate this. So first let us differentiate this. So derivative of rho with respect to time, e rho plus rho je amuk thamo, e rho je amuk differentiate toro. Rho d by dt of e rho. In cylindrical coordinates, e rho, the unit vectors along rho and the unit vectors along phi, they are not constants. They change from one point to another. So as the particle moves from one place to another place, this e rho may change. So the derivative of e rho with time may not be zero. So zero nothing because mamang the yang this is equal to phi dot e phi gamani high nika. Plus derivative of this. When the object moves, its z component can change. So this is dz by plus dz by dt. And this is a constant. Ez is always a constant. Ez is nothing but k ko samani ko. Ez k ko samani. Adana constant ina ez chirum thaman. So when we differentiate this, we get two terms. When we differentiate this, we get only one term because Ez is a constant, but E rho is not a constant. So we get two terms. So this is equal to derivative with respect to time. We have a dot half zero. So this is rho dot E rho plus what is d by dt of E rho? We have already proved that the rate of change of E rho with time is phi dot E phi. So this is nothing but phi dot E phi. So this will become rho phi dot E phi. And I call plus z dot Ez. So this is the velocity. This is the velocity of the particle. There's a rho dot. This is the velocity along the direction of rho. This is the velocity along the radial direction if we consider ourselves in a two-dimensional plane. So motion in a plane. Motion in a plane. Motion in a plane xy coordinate system study we can also study motion of a plane in cylindrical coordinates. So let me share my screen and show you an example. Okay. Can you see this? This is a book which is called Introduction to Classical Mechanics. Let me show you this. Let me close this. This is Introduction to Mechanics by Kleppner and Kolenko. Introduction to Mechanics by Daniel Kleppner and Robert Kolenko. If you have used this in your classical mechanics let me give you one example. Let me show you where you can find this velocity and acceleration in terms of plane polar coordinates. Section 1.9. Section 1.9, motion in plane polar coordinates. This is part of the Tenera. Discuss the report. Mechanics Mechanics book by Kleppner and Kolenko. Section 1.9, the motion in plane polar coordinates. This is plane polar coordinates. It is a two-dimensional plane polar coordinate. So in this case here, z equal to 0. Z is 0. If we come back to our example, quick example, the lagadi. Okay. For example, the what you do that you know, Sigiziga money, dr head by dt equal to theta dot theta head. I got. I coin r gimoto rho season of any theta gimoto 5 season of any. So in our expression, we use this d by dt of e rho equal to phi dot e phi season of any. D theta by dt equal to minus theta say the theta dot r head say I theta ki motor phi season so d phi by dt equal to minus phi head e rho the velocity is expressed so the I express the velocity equal to the d by dt of position vector is the position vector the position vector contain two terms, one containing r and r, rho and rho head, and another containing z and z head. And since this is a two-dimensional plane, z equal to 0, it has only one term, rho and rho head. The r and r head aduna sig derivative the kari phange r dot r head plus r dr by dt. Sig is niko. Aduna hojik the another term r dot r head. What is this? This is the velocity in the radial direction. And the second one r theta dot theta head. And what is this? This is the velocity in the tangential direction. So the velocity in the tangential direction. And what is this? This is the velocity in the radial direction. So this idea you will also come across when you study your mechanics. So let me stop sharing. So in two dimensions, this z will be 0. So this term will vanish here. So rho dot e rho. What is this? This is the component of the velocity in the radial direction. And rho times phi dot. What is this? This is the component of the velocity in the tangential direction. See hana loina kamai thena bayai rho ji mohut r and thena bayai phi dot ji mohut omega and thena bayai. So you might have come across this term as omega times r. And what is omega times r? Omega times r is a tangential velocity. I don't know how to explain omega r and thena. So the omega has come to phi dot ni r has no rho is and when omega r and thena target omega is a rate of change of angle with respect to time. That is angular velocity of omega. And what is r? And r high is the rho. Okay. So this is how we link what we learn in mathematical physics with what you learn in mechanics. Next, velocity. Next, let us calculate the acceleration. So to calculate the acceleration, let us differentiate the velocity. So acceleration. Acceleration. And what is acceleration? Acceleration is dv by dt. And what is v? So this is d by dt. As v the we obtain rho dot e rho plus rho phi dot e phi. So dot nika e phi plus z dot ez. So let us differentiate this again. See, differentiate also. So this will give you two terms. This will give you three terms. This will give you one term. So first, let us express this. So, Sithamasi, rho dot thamasi, e rho differentiate torsi, d by dt of e rho. Plus, siamu differentiate torsi, siamu thamasi, rho double dot e rho. Plus, siamu yang asi, so sini thamasi si hana differentiate torsi, rho phi dot, say that d by dt of e phi dot. E phi. C is yung tamaga phi dot yung differentiate torsi, so plus rho phi double dot e phi. So C is tamaga rho yung differentiate torsi plus rho dot phi dot e phi plus z yung differentiate torsi z double dot e z. So this is what we have obtained. So this is equal to C value of Z, C value of Z. So this is rho dot, and what is d by dt of rho? This is phi dot times e phi. So this is phi dot times e phi plus rho double dot e rho plus rho phi dot, and what is d by dt of e phi? This is minus phi dot e rho plus rho phi double dot e phi plus rho dot phi dot e phi plus z double dot ez. Now let us group terms. Term names group terms e rho term names group terms. Let us group terms containing e rho. So from this two, what do we get? This is equal to rho double dot minus rho phi square, rho phi dot square. So phi dot square equals this is phi dot square e rho plus e phi term jam group that this so rho dot phi dot e phi, rho dot phi dot e phi. So twice lani, so rho phi double dot e phi. So this will be rho phi double dot plus twice rho dot phi dot e phi plus z double dot ez. So this is the expression for acceleration in terms of cylindrical coordinates. This is the expression for acceleration in terms of cylindrical coordinates. Mechanics so Sigi meaning so that we go back to screen sharing again. So let us go back to page number. Okay, so is that page number 36 yoram dre, page number 36 magi preview yoram dre. So let me explain it to you. This first term is what? So So let me stop sharing. Let me stop sharing the screen. Okay. So this first term, rho double dot e rho. This is the linear acceleration in the radial direction due to change in radial speed. This is linear acceleration in the radial direction due to change in radial speed. Rho dot radial speed. So rho double dot rate of change of radial speed in the linear in the radial direction. Rho phi double dot. This is rho phi double dot. This is linear acceleration in the tangential direction due to change in the magnitude of the angular velocity. So omega omega high d phi dot. Omega differentiation. So d omega by dt times r. I don't know in the mechanics. So this is nothing but this is linear acceleration in the tangential direction due to change in the magnitude of the angular velocity. Angular velocity is phi dot. Phi dot is change. Phi double dot is 0. So if phi dot changes with time, phi double dot will not be 0, and so this term will be the linear acceleration in the tangential direction. Two-dimensional plane. So in two-dimensional plane, this is 0. So when we consider motion in two dimensions, this is linear acceleration in the radial direction. This is linear acceleration in the tangential direction. This term minus rho phi dot square. What is this? This is nothing but minus omega square r. This is minus omega square r. And what is that? This is the centripetal acceleration. Minus rho phi dot square. This is centripetal acceleration. Centripetal acceleration. E rho opposite the direct. This is directed towards the origin. So opposite to e rho minus sign. Additionally, 2 times rho dot phi dot. 2 times rho dot phi dot e phi. And what is this? This is called Coriolis acceleration. This is called Coriolis. 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 This is called Coriolis acceleration. Coriolis acceleration. Coriolis acceleration. Coriolis force. Have you come across the term Coriolis force? Okay. Fictitious force. A Coriolis force is a fictitious force which appear to act in a rotating coordinate system. Fictitious force. Fictitious force. Fictitious force. Frame of reference. Coordinate frame inertial. If my coordinate frame is not inertial, if my coordinate frame is accelerating, coordinate frames accelerate fictitious force develop develop fictitious force. Rotating frame if my frame is rotating, then it is not an inertial frame. In such a rotating frame, you will come across 2 types of forces, fictitious forces. Fictitious forces are usually amana centrifugal force. Merry-go-round the pump and the papalum, the push or Gari the corner turn to papalum, the push. There is a centrifugal force. The Coriolis force. This is also a fictitious force which appears in an accelerated frame. Coriolis. So mechanics. So